Hey, Geometry, welcome back. I know notes last time were a little bit sketchy. I had to do anyway, technology stuff. We're going to continue our talk through 8.1. We talked about ratios and proportions last class, and this time we're going to be talking about similar polygons. So those link hand in hand. Remember, solving proportions is just cross multiplying and then solving just like an equation. So we're going to move into really talking about how they apply to polygons. Remember, polygons are many-sided figures. So we're going to be talking about a few different polygons today. You can follow along in your notes that you have printed out, that are the blank notes on the site here, or the Canvas course here. Or you can just follow along in our notes journal and our math journal. We're going to be filling these out. So polygons are similar if two things. Polygons are similar if side lengths are proportional. Remember, equal ratios, proportional. And I'm going to put here equal ratio so we don't forget what that means. And then polygons are also similar if angles are congruent. So we talked a little bit about last time, even if you make, or we talked about in quadrilaterals, even if you make a figure bigger or smaller, the angles don't change. Like if I make a square bigger, it doesn't change the fact that it's a square, that all of the angles are right angles. It just changes the side lengths. So therefore, in a square, all squares are similar. Angles are congruent. So all of these are corresponding, and I want to talk about this word corresponding. So these are corresponding, sides are congruent, and corresponding angles are congruent. So let's think about those things. I'm going to put that in here. Corresponding angles and corresponding sides are congruent. That's okay. Hang on, let me pause my recording. Okay. So let's continue. We're talking about corresponding. So let's talk about what corresponding means. Corresponding sides go hand in hand and angles go hand in hand. So let's look at this. If my triangles are similar, so if triangle ABC is similar to triangle XYZ, then their corresponding parts are going to either be proportional, so sides will be proportional, angles will be congruent. So let's look at this. Angle A is corresponding to angle X, and therefore angle A is congruent to angle X. Angle B is corresponding to angle Y, so therefore angle B is congruent to angle Y. I'm going to label it with our little arches here. And then lastly, angle C is corresponding to angle Z, therefore angle C is congruent to angle Z. And now let's look at our sides. So we have side AB. Now I'm going to put these little squiggly, or we can put a little dot like we have a colon. Colon is the same thing. Remember we, I don't know, back in 7th grade when we talked about ratios, you can write ratios different ways. You can write them as a fraction, or you can write them with a colon. So I'm going to put a colon here. So side AB is not congruent to side XY, but it is proportional, right? Similar. Same thing for side BC. They're not congruent, they are proportional. Their ratios are going to be equal here. And then side CA is going to be proportional to side ZX, right? So that's what we mean by corresponding. So they're like matching, right? They're matching from figure to figure. All right. So let's keep going. I'm looking at example 4 in your notes. So example 4, we're going to determine if the figures are similar. So I'm going to say, are the figures similar? Take these notes with me because it's really going to help. So I have a larger right triangle here with sides 9, 18, and 3, and an angle of 37 here. And then I have another smaller triangle here. It is still right, and the sides are 2, 6, and 12, and my angle here is 53. Okay, so two things, remember. Figures are similar if, number one, the corresponding angles are congruent. So I want to see, are my angles congruent? Well, I'm going to get my calculator out just to see if all of my angles are congruent. So if this one is 37 and I want to find this one, I'm going to take 180, right? I'm going to subtract out that 90, and then I'm going to subtract out the 37, and I get 53. Okay, well, those are congruent, right? My right angles are obviously congruent because all right angles are congruent. So let's see if that's the case here. Well, I know if that's 53, this has got to be 37. So those are also congruent. So what do we know? All of our angles are congruent, so that's true. All angles are congruent, so that's a check mark. So are all sides proportional? Let's check. How do I know if something is proportional? It's equal ratios. So let's do that again. Let's have our corresponding sides. Let's set them up as ratios and see if they're equal. So I'm going to do this. I'm going to do larger to smaller here, 9 to 6, and then 18 to 12. And my last one is 3 to 2. So I want to see, are all of them the same? Are they equal ratios? So we can do this one of two ways. One, we can set them up as equal ratios here, cross multiply and see if that's true, right? So I can do this, 9 to 6, 3 to 2, and I can just see if all of them are the same, and then I have to do the last one, 18 to 12, and 3 to 2. So let's do our cross multiplying magic here. 9 times 12 is 108. Is 6 times 18 108? It sure is. So those are equal ratios, meaning those sides are similar. Let's see if it is true here. 9 times 2 is 18, and 3 times 6 is 18. So that's true. Let's see if our last set is true. 18 times 2 is 36, and 12 times 3 is 36. So that's also true. So all of my sides are proportional. The other thing I can do is I can just divide these and see if I get a similar scale factor. So if I did 9 divided by 6, I would get 1.5. If I did 18 divided by 12, I would get 1.5. And if I did 3 divided by 2, I would also get 1.5. So I proved it two ways that my sides are proportional, so check. So it says, are the figures similar? And my answer here is yes. Why? Because all of the angles are congruent. We proved that. And all of the sides are proportional. We proved that two different ways. We set up proportions and solved, right? Equal ratios. And I looked at their scale factor to see if their scale factor was similar, and it was true. Okay, so that leads us into another word that I want to talk about, and that is scale factor. So let's talk about this word, scale factor. Okay, so here is our definition of scale factor. Scale factor is the ratio of two corresponding lengths in two similar figures. In the case of the last two triangles, we found out that our scale factor was 1.5. That's my ratio of the lengths of the corresponding, right? My corresponding sides. Really easy way to think about this is just dividing the sides. That's the easiest way we can think about it. If I'm going from this one to this one, it's getting smaller, right? So I'm dividing it by 1.5, right? And if I go the other way, I'm multiplying it by 1.5. So that's the definition of scale factor, the ratio fraction. Remember, ratio is the same as fraction of the two corresponding lengths in two similar figures. So let's look at example 5 here. We have a few more. I know these are a little bit long in our notes here. What is the scale factor of quadrilateral ABCD to quadrilateral EFGH? So we're going to find the scale factor here. We already know that they're similar. This is A, B, C, D. Draw it with me. And label, remember we got to draw and label. 8, 6. And here is the smaller one. 3, 5, 4, and 2.5. So we have this little curvy line here in the middle. This line means similar, or this curly line means similar. That's what that little symbol means. It's the same as the thing above the congruent sign. Okay, so we know that they're similar because they tell us here. And we have some tick marks to prove it, that all of our angles are congruent here. So we can kind of tell what our corresponding sides are based on our congruent angles. So I can think about the one between 1 and 2. Those are going to be my corresponding sides. The one between here is going to be my corresponding sides. See these tick marks here, that's 3 and 4. Those are going to be corresponding sides, and those are going to be corresponding sides. So I want to find out what the scale factor is. We're just going to, it's the ratio of the two corresponding lengths, right? So the ratio, remember, is fraction. So here's my corresponding sides, 10 and 5, 10, 5, right? That's my ratio. Let's see if that's the same. 5, 2.5, 6, and 3, 8, and 4. If I divide all of these, I get 2. So guess what my scale factor is? My scale factor is 2. Ta-da! All right, and then it says, show that the ratio of the perimeters is the same. So the ratio of the perimeters ratio of perimeters is just adding them all up, right? So let's see if it's the same. I have 10, 5, 8, and 6. 10 and 5 is 15, and 14 is 29. That's a beautiful number. And then 5 and 4 is 9. 9 and 3 is 12. 12 and 2.5 is 14.5. So let's see if 29 divided by 14.5 is 2, and it is. So they are the same. So here's a truth here, or a theorem, is that the ratio of side lengths of similar figures, having trouble with my letters, is equal to the ratio of the perimeters, their perimeters. It's not the same for area or volume, but we won't get into that today. So when we come to class, we're going to go over example 9 and 10, and I will see you soon.